Worked example 15, calculating impedance of RL, RC and RLC circuits. Question 1. A AC series circuit with a 35 ohm resistor and 150 millihenry inductor is connected to a 50 Hz 120 volt supply. Part A, calculate the supply current magnitude only. Just like in the previous question, we're going to be working out our impedance, but this time we've got multiple components, so our impedance is going to be slightly more complicated than just R, XL or XC. It's going to be a combination of these two parts together. However, the first thing we're going to need to do is work out our XL, and then from there work out our impedance, and then from there we can work out our supply current. So let's start off with XL. So XL is equal to 2 pi FL, and that 2 pi F is going to become 2 pi times 50 times our inductance of 150 times 10 to the minus 3. And that becomes 15 pi in the calculator, or when we convert that, that becomes 47.12 ohms. In the question, you can see there is no capacitor present. When we work out our reactance overall, X being equal to XL minus XC, basically our XC becomes 0 because there is none. So X just becomes equal to XL, which is 47.12 ohms. So our X and XL are the same in this case. So now we're actually ready to go ahead and work out our impedance, Z, which is equal to R squared plus X squared, square root of all. So this is if you're just working out the magnitude. We're not really dealing with rectangular numbers at this point. So we can go ahead and substitute in our resistance and our reactance and work out our overall impedance. So square root of resistance 35 squared plus our reactance of 47.12 squared, and that gives us a total impedance of 58.69 ohms worth of impedance overall. From there we can now work out our supply current, which is equal to V over Z, and in this case it's going to be our 120 volts divided by our impedance of 58.69 ohms, which gives us a supply current of 2.04 amps. Question 2. A capacitor and a resistor are connected in series to a 230 volt 60 Hz supply. Capacitor is 150 microfarads and the resistor 22 ohms. So just like in the previous question, part 1, except this time we're dealing with a resistor capacitor, there is no inductor, so XL will be equal to 0 in this case. So X is only equal to XC in this example. So X equals XL minus XC. There is no XL, so X equals XC. Capacitive reactance here, XC, is going to be equal to 1 over 2 pi FC, which is going to be equal to 1 over 2 times pi times our frequency of 60 multiplied by our capacitance of 150 times 10 to the minus 6. 17.68 ohms. From there we can go ahead and work out our total impedance of R squared plus X squared, which equals 22 squared plus our 17.68 squared root of all, which gives us a total of 28.22 ohms of impedance. Of course, we're not finished. That's just our total impedance for the circuit. We can now go ahead and work out our IS, which is going to be equal to VS over Z total, or the Z we just worked out. And in this case, that's going to be 230 divided by a ZT of 28.22, or 8.15 amps of supply current. Question 3. An RLC circuit is connected to a 50 Hz 230 volt supply and has the following values. R is 15 ohms, L is 159 millihenries, and the capacitance is 80 microfarads. Determine the supply current, and again magnitude only. So in this case, we need to calculate both XL and XC so that we can get our total X, and then using total overall reactance calculate our impedance. So XL is 2 pi FL, which is 2 times pi times frequency of 50 times our inductance of 159 times 10 to the minus 3, and that gives us a total of 49.95 ohms. XC, 1 over 2 pi FC, is equal to 1 over 2 pi times frequency of 50 times our capacitance of 80 times 10 to the minus 6, and that gives us a total of 39.79 ohms of reactance, capacitive reactance. X, our overall reactance, is XL minus XC, so in this case 49.95 take away 39.79 leaves us with an overall reactance of 10.16 ohms. So from there we can then go ahead and work out our overall impedance, Z, which is the square root of R squared plus X squared, which is equal to the root of R squared, which is 15 squared plus 10.16 squared, and that gives us an overall impedance of 18.12 ohms. Finally, we can say that our supply current is going to be equal to our supply voltage divided by our total impedance, and that is going to be equal to 230 divided by our 18.12, which gives us a supply current of 12.69 amps.